The Paleocene epoch is the oldest in the Cenozoic era. The Paleocene epoch took place from 65.5 million years ago to 55.8 million years ago. The Paleocene epoch was separated from the Eocene epoch in 1874 when W. P. Schimper found differences in the plant fossils he was studying from the two epochs and separated them. The Paleocene epoch is subdivided into three different ages. The oldest is the Danian stage, which is followed by the Silurian stage, and lastly, the Thanasian stage. This epoch begins right after the Cretaceous extinction, which killed off the dinosaurs and many other types of life, and the primary source of information for this presentation comes from the Smithsonian National Museum of Natural History website. After the Cretaceous extinction, life on land was much different than it was before the extinction. Mammals and birds became the main land vertebrates, replacing the previously dominant dinosaurs that were wiped out during the extinction. The diversity and number of these animals increased as the epoch progressed, but because of the Cretaceous extinction, the epoch began with very few large animals. This epoch is known as the beginning of the age of mammals, but as far as fossil evidence for the different vertebrates is concerned, we don't typically find many fossils of birds. There are some, but they're very rare. But we do find a much wider variety of fossils from mammals, and the mammalian fossils that we have from this period include insectivores, carnivores, herbivores, and even early relatives of primates. The largest mammal that was alive during this time period was a primitive plant-eating animal that was approximately the size of a small pony. And during the end of the Paleocene epoch, we see the emergence of rodents. And in addition to all of the wide variety of mammals that are present in this epoch, there's also some evidence of evolution happening. And so we see two different big evolutionary changes during this epoch. And the first is the evolution of teeth. And what I mean by that is you can start to see a difference in the tooth structure of an organism based on its diet. So this means that if you compare an herbivore to a carnivore, you can see differences in their tooth structures. And a second evolutionary change that we see during this epoch is that animals are starting to adapt so that they can run faster and more efficiently. In addition, we also see multituberculates, which are rodent-like mammals, present during this time period. And this order of mammals existed for about 100 million years, which is the record existence for an order of mammals. And many of the fossils that we find from this epoch actually are found in North America. Fossilized leaves from the Paleocene epoch can also tell us a lot about the herbivorous insects that lived during the time. So what we find in the leaves from the beginning of the epoch is that there isn't much damage to the leaves caused by insects, but if you look at leaf fossils from the end of the epoch, you see that they have a lot more markings on them, both a larger number and a larger variety of markings. And these marks on the leaves suggest that in the beginning of the epoch, there weren't as many insects because of the extinction that occurred, and it took them a while to recover in both numbers and in variety. And what we see at the end of the epoch is that at the end of the epoch, we know that there's a larger diversity of insects because of the wider variety of markings that are present on the fossilized leaves. Most of the plant life did not survive the Cretaceous extinction. For a brief time in the beginning of the epoch, right after the extinction, we find that ferns were very abundant. Some other widely occurring plants during the epoch include flowering plants and conifers. And if you look specifically at the swampy forest land, deciduous trees were very common, and the trees that we find in those forests are related to the bald cypress tree, which is currently found in many parts of the United States. And then in areas that had drier ground, there's a variety of tree, laurel, and birch trees growing. Life in the oceans also changed between the Mesozoic and Cenozoic eras. The Cretaceous extinction affected the larger animals from the Mesozoic era, and after the extinction, many invertebrates and fish survived, but there was only a limited number of aquatic reptiles that survived, and the only aquatic reptile survivors of the extinction were turtles, crocodilians, and champsosaurs. And champsosaurs are crocodile-like fish eaters that live in freshwater. During the Paleocene epoch, bony fish also became much more common, and some of the new sea creatures that were found during this epoch include urchins and foraminifers, and in addition, there are more modern gastropods and bivalves found during this epoch. And during the Paleocene epoch, most of the continents had separated from the supercontinent of Pangaea, and for this reason, I will describe the location of the continents using their present-day terminology. So let's go ahead and start in the southern hemisphere with India. So India was moving north towards southern Asia during this epoch, and the two landmasses actually began to collide during the later portion of this epoch. This collision of landmasses continues today, and at the convergence point of these two landmasses, the Himalayas are formed. And during this time, Australia and Antarctica had already separated from each other, and Australia was moving towards the north. As far as the Western Hemisphere, we find that North America and South America were separated by a seaway, which means that the Atlantic, the Pacific, and the Indian Ocean were all connected. And we find that South America and Antarctica were still connected by a very small peninsula. North America was connected also both to Asia and Europe. The connection between North America and Asia is commonly known as the Bering Land Bridge, and during this epoch we also see that the Rocky Mountains began to form. At the end of the Paleocene epoch, the Earth warmed by approximately 5 degrees Celsius as a result of a large release of carbon. Analysis of samples taken from the Marlborough clay show that the initial release of carbon was rapid, if not instantaneous, and based on the conditions of the carbon increase, there are two different mechanisms by which the carbon increase is theorized to have occurred. The first mechanism is that there is a large release of thermogenic methane, and the other possible source of carbon is cometary carbon. And this second possible source of carbon is consistent with some of the evidence that was found in the same samples of Marlborough clay, and this evidence is non-biogenic magnetic nanoparticles. And during this epoch, we find that the climate of nearly the entire Earth is subtropic. The maximum warmth occurred about 55 million years ago at the very end of the epoch. And during this time, seasons were likely alternations of wet and dry seasons rather than large temperature swings. So this means that the climate of Earth during the Paleocene epoch is similar to what is found in countries near the equator today that do not experience large temperature differences, rather than they have differences in the amount of precipitation they receive depending on what time of the year it is. The Paleocene epoch was filled with a variety of land and marine life. It was the beginning of the age of mammals, and the continents were beginning to separate and move to the positions that we find them in today. During the end of this period, the Earth warmed to a point where the worldwide climate was mostly subtropical.